Hello students, welcome once again to our YouTube channel. Please do like and share the video and do subscribe the channel. If the questions are useful, see that's something new, something different, a different question all of a sudden, because we were from few days we had been solving the question of definite integration on one side and the theory of equation on other side. See, this question I got as a comment on one of my video. The student who requested me to please make a video on this. So I will like to tell you all that if you have any genuine question, see, why am I saying genuine question? Because see, you should, that's a very simple thing. If you start testing me, that let's see whether he can solve the question or not, that won't serve your purpose. Okay, so if you have any question which you feel, okay, this question is you feel or your friends feel that it's a good question, for someone tell them that it's such type of questions are good question and you're not able to solve them, okay, then I will ask you all to do share the questions to me with the help of comment box. Like I got this question as a comment, and I can assure you that I will try my best to make a video on it, of course after solving it. Okay, so I tried to solve this question, spent some time, got the solution. So answer is there or not, that's the second thing, but I am definitely going to discuss how I thought on it and how can we approach such type of question. Okay, so again I am saying, if you people feel that you need to have the solution, the procedure, the method, the concept involved in a particular type of question, do share the question. I will definitely try my best to solve it and share its solution with the help of video here, okay, on the YouTube channel, on our channel. So that's the question. Let A, B, C, D and E are vertices of a regular pentagon A, B, C, D, E. If vector A plus vector B and lambda times vector A and lambda times vector B are the position vector of the vertices A, B, C, D and E respectively, then we have to find the ratio in which line segment AD divides line segment EC. Okay, so now see how I started looking at the vertices. So if I draw a pentagon here, it might not seem to be a regular pentagon though. So if I draw a pentagon here, something like this, let us assume it's a regular pentagon, okay, with vertex A, B, C, D and E. Now look at the position vectors of the vertices given. The position vector of vertex A is vector A, vertex B is vector A plus vector B, vertex C is vector B, vertex D is lambda times, lambda being a scalar of course, vector A, and vertex E is lambda times vector B. Now what is position vector of a point? Position vector of any point A is nothing but its position with respect to the origin and from origin towards that point. Okay, so now position vector of A is OA, vector A, and position vector of D is OD, which is again some scalar times vector A. Okay, so now what I thought is that, okay, let's join AD because we need the point of intersection of AD and BEC, AD and EC. So this is, which point is it? So I said that this is going to be our origin. Why so? Because then only OA and OD, they are collinear, they have to be collinear. Lambda times vector A is collinear to vector A. Similarly, lambda times vector B is collinear to vector B, and since vector B is OD, position vector of D, and vector lambda times vector B is OE, position vector of E, so these 3 points are collinear. Similarly, A, O and D are collinear, and where they meet? They meet at origin only. So this is the point which we where they meet. Okay, now the point is we have to just get lambda here. Now what I saw, I observed that this is vector A plus vector B, and this is vector A and this is vector B. Now try to recall your parallelogram type of thing. Okay, so in a parallelogram, if this is vector A and this is vector B, then this is your vector A plus vector B along the diagonal. Okay, so if I complete a parallelogram, Okay, then this is your vector A plus B. So what does that mean? That means this and this are parallel and of equal side. This and this are parallel and equal side. Okay, so this angle. So what's the angle of a internal angle of a regular pentagon? So how do we get it? So for that we know sum of all interior angles of a n-sided polygon. How much is it? Interior angles of a n-sided polygon is n minus 2 into 180 degree. So therefore for pentagon the sum of all interior angles will be how much bachcho? So 5 minus 2, 3 into 180 degree, which is 540 degree. So since it's a regular pentagon, all angles have same measurement, all interior angles are equal. So what will be the measurement of angle B? So angle B is nothing but 540 divided by 5, so it is 108 degree, which if I express it in terms of a radian, 180 degree is pi radian, so it is 3 pi by 5. So how much is it? It's 3 pi by 5. Now combine few information. We know this angle. Now since OABC is a parallelogram, why? These are two adjacent sides of a parallelogram, and that's the resultant vector or the vector along the diagonal. Okay, so that's a parallelogram. So what does that mean? This angle at O is also 3 pi by 5. So what is it? This is the angle between vector A and vector B. So we got angle between vector A and vector B, and moreover, see, what was I saying? Right. See, it's a parallelogram. Okay. So now see, join AB. So AB vector is position vector of B minus position vector of A. Of course, it's B, and this is nothing but BC. It's A. Okay. Now see, or minus it doesn't make any difference, because what am I going to use is the magnitude. Since it's a regular pentagon, so magnitude of A, because AB is equal to BC, all the sides are of equal length, magnitude of A is equal to magnitude of B here. Now what? See, to get lambda, what I use that this is equal to, so DC, so length of CD, let's say vector CD, which is the side length CD here, is equal to any like AB, BC, whatever, so which is equal to magnitude of A. So how much is CD? So CD is lambda times A minus B, mod is equal to mod of A. We should remember that mod of vector A is same as mod of vector B. Okay, now squaring both the sides. So what do we get? Lambda vector A minus B whole square is equal to magnitude of vector A whole square, and we know magnitude of any vector square is nothing but its dot product with itself. Okay, so using it, so you will get lambda times vector A minus vector B dot product with lambda times vector A minus vector B is equal to, let us keep it as A dot A. Okay, so now just use it. So lambda square vector A dot vector A mod A whole square. Lambda, so vector B in dot vector B is mod B whole square. So let's write mod B. Anyways, it is equal to mod A whole square. And then minus 2 lambda A dot B. A dot B. So magnitude of A, magnitude of B, cos theta. Theta is angle between vector A and vector B. Now this and this gets cancelled because they are equal, and magnitude of vector B is same as magnitude of vector A. So lambda square magnitude of vector A whole square minus 2 times magnitude of vector A whole square cos theta is equal to 0. Okay, so now cancel lambda here, common, so they and vector A square, magnitude of vector A square is also common, remove it, so you got lambda here. So lambda is nothing but 2 times cos of 3 pi by 5 theta. Theta is the angle between vector A and vector B, and it's nothing but 3 pi by 5. Okay, and see, looking at the figure, that makes sense also the way I took it. So that justify it, because they are in opposite direction, and we know cos 3 pi by 5 in which quadrant? 108 degree. It's in second quadrant, and cosine is negative. Okay, so lambda has to be negative, then only they are in opposite direction, bachcho. Fine. Now what? Okay, now we know lambda, so this is 2 cos 3 pi by 5 times vector B here. Okay, so this is origin, this is vector b, and this is a position vector of E lambda times vector b. Now I will say that let origin divides it in the ratio k is to 1, because origin is the point of intersection of AD and EC. So if AD divides EC in a ratio, of course it will divide it